7 QC tools or 7 quality control tools are very powerful tools used in quality control and design departments to collect the data in a systematic manner and root cause analysis of the problems. So without any further delay, let's study these tools. And yes, do subscribe to the YouTube channel and do not forget to press the bell icon. The 7 QC tools are checklists, process flow chart, or they are also known as process flow diagram, both are same, histograms, Pareto charts, cause and effect diagram, control charts, and scatter diagram. So let's study them one by one. The first QC tool is check sheet. Check sheets allow us to collect and aggregate data in easy and effective way. So as shown in this example, we have multiple defects listed down in the part, and we have collected data in a way in which we list down these defects for every category as well as for every hour. Now the advantage of this data is, in the single collective sheet we will understand how many total defects are appearing in one shift. We'll also understand how many defects are appearing per shift in each category. We'll also understand how many defects appearing in the part per every hour. And this data is going to give us totally different perspective as far as the distribution of these problems concerned. Check sheets eliminate possibility of skipping any essential inspection item. So what does it mean? So for example, if we have to submit PPAP, which is nothing but production part approval process, you know already that, and there are 16 documents and records which are part of this PPAP. Now if we try to remember all these documents, it will be very difficult because there is a possibility that something might miss out. But if you list down these documents and then you can verify and tick the documents and records which you already completed, that way it will give you an overall synopsis of how many documents records are ready, how many documents records are pending, and that way there will be less possibility of missing something very important. Check sheets are also very effective in categorization of the data, which we have already studied here. Second QC tool is process flow chart or process flow diagram. PFC lists down each step in a process with the help of boxes and arrows, and they show the flow of the process. This is also called as visual representation, which makes it easier to understand the entire process on one single sheet and one go. Now PFC helps us to quickly analyze the entire process very easily. Now these are some of the boxes which are shown into PFC or PFD. So we have a start and end, then we have data, manual inputs, process, decision, and decision might be yes or no, and then we have documents. So there are different signs, different boxes to represent different kind of information. Let's see one example. In this example, we start manufacturing a part and shipping it and packaging it, and this is a molded part. So we are starting here, then we have raw material. With this material we are going to process it. That means first process is the melting of raw material, then second process is molding, which is injection molding we can consider. The third process is inspection. In inspection we are going to take the decision. We are going to ask whether it meet the specification or not. If the answer is yes, we are going to pack it and we are going to ship it, and that will end the process. If the answer here is no, that means it is not meeting the specification, then we might rework it, and in rework we are going to ask this question again whether it meets spec or not. If it is not meeting, then we are going to recycle it or reject it, and if it is meeting the spec, then we are going to go for packaging and shipping, and that will end the process. So you can see this entire process on a single sheet and understand that very easily. That's the power of process flow chart. Process flow chart is one of the mandatory documents for PPAP submission. The third QC tool is histogram. This is another powerful tool which we use in data collection and representation. We have already seen a checklist. This is a form of collecting the same data which we collected in a checklist but in a visual format. So as you can see here, we have different temperature ranges and then we have frequency of the part in each temperature range. So by just looking at this, you will understand how many parts are falling under each temperature range. Histogram is an effective tool to group a range of data into smaller sections, and they should have uniform span. That means 200 to 220, 220 to 240. So they have uniform span, otherwise it will be very difficult to compare. And then we are going to list down their occurrences, that means which is called as frequency. Frequency is nothing but how many parts or how many incidences happen during that particular span. Histogram uses bars and each having height proportional to the number of occurrences in each section. Histogram is very important information when we will go for Pareto principle. Pareto analysis or Pareto principle is another very important QC tool. Now so far we use checklist and histogram and process flow diagram in order to collect the data. But out of the collected data, which data is very critical in terms of giving the output? This analysis could be done easily with the Pareto analysis or Pareto principle. Now, Pareto principle works on 20-80 rule. Now, what is this 20-80 rule? It shows that 20% of the root causes are responsible for 80% of the result. Or, in other words, if you take care of 20% of the root causes, it can give you 80% improvement into the results. Basically what we say is, if you find out those 20% of the root causes, then we can improve the results by 80% by taking care of those. So here is one example. These are all defects in handwriting or incorrect writing. Out of that, broken links, spelling errors, missing title tag and missing description tag, these have lot many frequencies. So if you can see here, these are histogram, right? And histogram shows the frequency. That means for broken links, how many defects we have observed. For spelling errors, how many defects we have observed. So left side shows the counts of errors. And these histograms are arranged as per descending order of their frequency, their occurrence. Now, right side we have a cumulative percentage. So what is cumulative percentage? If we add all the counts of all these defects, that will be called as total count. And then out of total count, if we start calculating the percentage, that means suppose broken line or broken links have 480 frequency, okay, 480 frequency. So if we calculate this percentage, 480 divided by total count, that means addition of all the counts, then we get percentage contribution of broken links in total errors. Similarly, if we calculate percentage for this, percentage for this and percentage for this for every instance, then what we have to do is we have to calculate that cumulatively. So what is cumulatively means? First thing, we have to arrange all these defects in a descending manner. That is very important because we want to list down the most frequency defects towards left side or towards one side. Okay, that is the purpose why we have to stack. Then you calculated the percentage of this, that was our first percentage. Similarly, you calculated the second percentage. The second percentage will be now addition of this plus this. Okay, that's how I am going to get cumulative percentage. So these are all cumulative percentage. Now what is the significance of this? If I draw the line which meets the 80% and which meets the curve, and then I draw vertical line coming out of that, then I know that this 20% of the defects contribute into 80% of the results. So that means if I take care of these 3 defects, then I can improve my results almost by 80%. So all these defects will be reduced. You can imagine, because all other defects are there not contributing much. These 3 defects are contributing a lot, and if I take care of them, then I'm going to get huge percentage of improvement. So that is the power of Pareto diagram. Pareto diagram is a combination of bars and line graphs of accumulated data, means cumulative data. The name Pareto came from the Italian mathematician who invented this concept. Pareto analysis helps us to identify and prioritize problems to maximize the effect of the action. Next QC tool is cause and effect diagram. Now we have understood how to collect the data, how to represent the data, how to in fact prioritize the data, right? Prioritize the root causes. Cause and effect diagram is another powerful tool to identify root causes of the problem. Now there are many methods of root causes, but when problem is complex and there could be multiple root causes of the same problem, then cause and effect diagram is going to help us. This is also called as a fishbone diagram or Ishikawa diagram, because this was invented by the scientist called Ishikawa, and this is called fishbone diagram because it looks like the skeleton of the fish. Okay, that's why it is called a fishbone diagram also. Now what this diagram focus on? This diagram focuses on relationship between the effect, that means result, that means problem, and what are its root causes, possible root causes, which we can categorize. Okay, so in one diagram you are going to get overall synopsis of the defect and the relationship, possible relationship with the possible causes. This is how your cause and effect diagram will look like. So you list down your problem here, and then you have different categories. You can have categories in terms of measurement, equipments, people, material, methods, environment. This is a very typical format, but it is not necessary that you have to put in this format only. This could be different part interfaces, sub assemblies and subcategories, and that's perfectly all right. But finally what we are trying to show here is the subgroups. Okay, these are the subgroups under which we are going to list down various root causes, possible root causes, which might affect this end result or which might contribute into the end problem. Now obviously all the root causes are not going to equally contribute into this problem, right? So we have to do further studies in order to understand which are the critical ones, okay, critical root causes which are contributing into this problem, and we have to work only on those, not on all, because here also Pareto principle applies that only 20% of the root causes might be responsible for this problem. Sixth tool, which is very important again, which is scatter diagram. Now scatter diagram is generally used to identify and conclude if there is a definitive relationship between two factors. So for example, in this we have income and we have health index, and we want to understand if there is a relationship of income of the person and the health index. So there are different dots which are scattered here, okay, and this is income and this is health index. So we are going to ask what is your income, we are going to check health index, and then we are going to put that dot. So scatter diagram can lead us to this kind of relationship, line relationship, which we can get from, you know, graph, and this will help us to understand if there is a definitive relationship between these two factors or not, or there is no relationship. Now how we know that there is no relationship? Because then it will be too much scattered. If this frequency is like too much scattered, then we know that there is no definitive relationship. But if this frequency is like accumulated and it follows certain pattern, then we can very well conclude that there is a relationship. So a scatter diagram is used to study the relationship between two paired interrelated type of data. So you cannot just take any random data, okay, you should know that there is a relationship exists and you just want to confirm that, verify that, okay. A scatter diagram helps us to find whether two data types are interrelated or not, and how closely they are related to identify the problem. Once we know the relationship, then we can very well take plan actions in order to solve the problem. Seventh very powerful tool again is the control charts. Now control charts is another tool to control the process. Control the process. So what is process means? So for example, if I have a part here which has a 20 mm dimension, okay, this has a 20 mm dimension and it has tolerance of plus minus 1 mm, okay, it has a tolerance of plus minus 1 mm. Now I'm going to manufacture this part and I'm going to collect lot of data of actually manufactured part. That means I'm going to get lot of dimensions, and by studying these dimensions I can very well understand whether this process is in control or not, because in any given process there will be lot of factors which are going to affect. So there will be manufacturing variation, material variation, workers variation, inspector variation, environmental variation, right? The measuring equipment variation, tool setup variation. So many variations are going to contribute into manufacturing of this part. So if I study this with the control charts, I can very well understand whether my process is in control or not. So control charts are used to establish stability of the process in consideration. There are X bar, R bar chart. X bar means mean chart, R bar chart means range chart. There are P charts. Okay, so many type of charts are there which can help us to control these processes. Now control charts are prepared from data collected over time and examined to study their distribution in the specified limit. So what is limit means? The limit here is 20 plus minus 1, that means 19 and 21. So those are limits. So how actual data is varying between 19 and 21, that's what we are studying here, okay, and that's what data we are collecting. But when we collect data, we cannot just collect randomly. We have to prepare a sampling plan, and this sampling plan should be prepared considering all the variations. So for example, I can say that I want to collect data per every shift, whenever tool setup changes, whenever new inspector comes, whenever material batch changes, because I want to make sure that all the variation is captured into this data. Then only this data will show us real picture. Now control charts help us to identify common and special causes and plan appropriate countermeasures. Now what are common causes, what are special causes, we are going to study shortly. Control charts are also help us to verify effectiveness of the countermeasure. So for example, if we understand the process is not under control and if we take countermeasure, then we have to understand whether it is effective or not, and for that again we can do control chart and we can check the stability of the process. This is an example of X bar chart, and the reason why I am showing it is because I want to show you special and common causes. So what are special causes, what are common causes? Special causes occur because of special outlier regions. So you can see sudden your measuring process is going everything fine, and sudden you see a spike. This parameter goes totally out of the limit. Now why this kind of thing happen? This kind of thing happen because of special causes. Now special causes are sudden changes into the process, which probably you know, which are predictable. For example, if you are traveling on the same road again and again, and every day you take time to reach in 20 minutes. Now every day it's not going to happen that you are going to reach in 20 minutes, right? Sometimes you'll reach in 19 minutes, sometimes you will reach in 21, 22 minutes. So that normal variation we know. This normal variation happens because of common cause. For example, there will be certain delay in traffic. There will be many vehicles on the road that day, particular day. So little variation here and there going to happen. Okay, but special causes are different. Special causes might happen once in a while. Okay, like some accident happened on the road. Now instead of 20 minutes, it took you 30 minutes or 35-40 minutes. It is an outlier, but it is not going to happen every day. Okay, so same thing happens with the manufacturing process also. There will be regular causes which might happen into the process, and because of that this variation is going to happen into the process, which is perfectly all right. But there will be certain processes, there will be certain instances like this where special cause occur, that means something unusual, something environmental change, something suddenly electricity went off, something is going to happen which is going to throw this part totally out of your limits, and that is called special cause. It's easy to control special cause. Sometimes it's very difficult to control common cause. These are uncontrollable most of the times. So hopefully now you have understood all 7 QC tools. You can use them in your projects and get the good results. Thank you for watching this video. Hopefully you learned something new today.